This is an early look at the pre-web app for MSC Nastran. So this is what I'm going to show you in today's demo. I'm going to take this Nastran model. I'm going to define two new forces, two new load cases. We are going to run Nastran, and then we're going to look at the deformations all through a web browser. This is the pre-web app. Today we're using Mozilla Firefox, but you could use the pre-web app in Google Chrome, Microsoft Edge, Windows, or Linux. Now, if you want to follow along with this demo, you can visit theengineeringlab.com. Here in the home page at the top right hand corner, you can click on the blue button, fill out the form, and you will get a free trial, free version of the pre-web app. Now, this all starts at the home page of the web app. You click on the viewer here on the right, and you upload your existing Nastran model. So let's upload the bulk data file. Here, let's take a quick look at the loads and the boundary conditions here on the right. If I rotate the model, here are some of the forces, some of the boundary conditions that exist. Now, I want to create two new force entries for this Nastran model. So here on the bottom left, we'll click on pre. We'll look for the force entry. And then here, let's go ahead and click on create entry. And then here on the right, we have the existing force entries. But now I have two new force entries, force 31 and force 32. Those are going to be the two bottom rows in the table on the left. Now, let me do this. Let me move this to the side. Let's go ahead and pick a node where to apply this force. So let's zoom in. Let's pick this node. Let's go ahead and do that for the second force and pick this node. So here you can screen pick the nodes, or you can manually modify the grid IDs in this input. It's up to you. Here on the right, we see that field 3 now has the grid ID. Let's go ahead and configure the direction of the node. Let me move this to the side again. Let's go ahead and configure the first node. Let me zoom out. So here you can see we have a new arrow. We have two new arrows. They're overlapping each other, so it looks like there's one. For the first force, let me make it go in the positive Z direction. For the second force, let me make it go in the positive Y direction. So whenever you modify something in the input table, the Nastran model is updated on the left. Also, whenever you modify this input table, the corresponding bulk data entry is updated for you. So now let's go ahead and modify the magnitude of the force. So now field 5 is updated for you with 500. So we're done with defining the forces. Let's go ahead and define two new subcases. So we'll jump to the case control section. We'll click on add subcase. And let's go ahead and look at the case control section on the right. Now we have subcase 10 and 11. Let's go ahead and define a subtitle, load case 10 and load case 11. And now you can see I have two new subtitle commands on the right. Now I need to take that force. I need to take the two new forces, 31 and 32. I need to apply them to subcase 10 and subcase 11. So this part is just marking the checkboxes. So if you look at subcase 10 and 11, I have a new load command. So load is pointing to force 31. Load is pointing to force 32. Once I'm done with that, I'll go ahead and run Nastran. In this window, you can specify the Nastran version, the input file, and keywords. So if you want to specify the amount of memory, you can specify a keyword for that. Here, I get the familiar output that you would see in the command prompt or Linux terminal window. An estimate of the memory. You get the message, Nastran beginning job model, Nastran job completed. So I'm just trying to prove to you we're running Nastran. We're working with Nastran all through a web browser. In the result file section, you see the log file, the F04 file, you see the F06 file. Here in this other table, we see the input file and the output files. You could click these individual links, and this would download local copies of the F04 and the F06 file. Here, let me open the F06 file. Let me prove to you that this is actually Nastran. So here, if we look at the top of the file, we see that this is MSC Nastran version 2025.1. We look at an echo of the case control section. We see subcase 10 and 11 that we defined a moment ago. And then we see the results of the Nastran analysis later on. If you want to, you can mark all the checkboxes, click on download selected files, and then you get a zip file that contains all the input and output files for this exercise. Now, the web app is currently running on my own laptop. If you want, or rather, let me take a step back. I downloaded an installer for the web app. I installed the web app on my laptop. I'm using the web app on my own laptop. If you want to, you can install the web app on a central server of your own within your own company. You can install the web app on a Linux server as an example. You run you upload your file to that Linux server. You run Nastran, and then you click download to recover the result files. Or you can just go ahead and look at the results all through the web browser. So here, let's go ahead and jump to subcase 11. And let me do this. Let me hide the force and let me display only this force. Let's go ahead and scale the scale factor so the deformation is more pronounced and noticeable. So this is before deformation and then after. Before and after. I can go ahead and display some maximum labels so I can identify where the highest value is. You can also do this for the minimum. So here we are told that the minimum displacement is at grid 574. So I'm assuming that's where we have a boundary condition there, a support maybe. Okay, now we can take a look at other values. So if you want to look at the stresses, let's go ahead and select the stress data set. Let's look at maybe the stresses at the corners of the element. Let's go ahead and display the location of the maximum stress. So here I'm told that the maximum corner stress is happening at at element 34, grid 33. If you want to, you can display additional labels. So here 10 labels are now displayed indicating where the highest stresses are located. Now, we look at this, and sometimes what happens, you realize that something was not configured properly. And in this case, let's assume that the force is going in the positive y direction, but we actually want the force to go in the negative y direction. So what do? We go back to the pre-web app, we'll look for that force, and we modify it. So let me move this to the right. As a reminder, anytime you modify something in the input here, the Nastran model is updated for you. So now you see the force is going in the negative y direction. Also, the corresponding bulk data entry is updated. If you look in field 7, before it was positive, so positive 1 here in field 7, but then we made it negative, and now we have a negative 1 here in field 7. So once I'm done with that modification, I go ahead and download and click immediately run. And it's the same loop, if you will. Specify the Nastran version, keywords, you look at the outputs, you look at the F06 file during the analysis. Now, once that's complete, you could jump to the corresponding load case. And now if we look at the deformation, you can see the deformation is now going in the negative y direction. So we saw a few things here. Number one, this is all through a web browser. We can configure the Nastran model in a web browser. Google Chrome, Microsoft Edge, and Mozilla Firefox are supported. You can do this in Windows or Linux. Now, we also saw the ability to create force entries. We saw the ability to modify the case control section. We looked at stresses and displacements all through the web browser. There's one thing I didn't cover. How do we handle errors? So here, let me show you what an error looks like in the web app. Here, I'll click on Create Entry. On the right, you'll see that I've created force 33. And I'll just try and run Nastran. When there's an error, you get a few error messages here. you get told that there's a UFM in the log or F06 file. Here on the right, I get a preview. It's not a preview, but it's a part of the F06 file. If you look through the F06 file here on the right, we highlight the location of the error messages. Here I get told that there's an error with one of the force entries. I forgot to specify the G field, the G input. What's the G input? So when you go here, you can click on display descriptions, and we show you descriptions for each field. Field G, field C ID, field F. Here, field G is a grid ID. I forgot to actually pick a node for that force, so that's why we're having an error. So what I can do here, I can go ahead and pick a node on the screen, and then I can go ahead and run Nastran. But instead of running a full Nastran run, I can click on inspect here on the top right. This will run Nastran, but only to inspect the bulk data file for any initial issues. So here, let me show you that force again. Let me clean this up again. Let's just focus on, was it 34? I forgot the ID. Let's go ahead and look at the last ID. The last ID is 33. So again, let me make a mistake. Let me leave out the grid ID. And then if we try and rerun this, we are going to get an error because there is no grid ID. So here, you see the user fatal message, and here, let me fix this. I forgot what grid ID it was. One alternative, you can just manually type in the grid ID. That's carried over and updated. Now you click inspect. And again, we're running Nastran just to test the bulk data file to see if there are any problems. Here, there are no problems. So once there are no initial problems, you can then move on to a full Nastran analysis. Now, we were debating internally. We were debating if we should give you individual checks, and we realized that, you know, the best option was just to run Nastran. If Nastran runs it okay, then you fix the issues. One long-term goal is to maybe implement AI in the tool. So AI will look at your fatal message. It would help you address where to fix the error. It would give you recommendations. So the goal in the future is to hopefully have AI implemented in this to help you fix a lot of those user fatal messages. Okay, now one other thing before I move on. A lot of the time, you have a structure like this where you have to go within the model to look at your structure. Maybe you have to look at results. Maybe you have to look at how the elements are connected. Suppose, as an example, I want to fly through this hole. I want to look at the hole from the inside. How do we do that? You can click on first person mode here. Let's go ahead and enter controls. You can move through the model. You can fly through the model like a video game. So here, this is the hole I want to look inside of. Let's go ahead and fly through the hole. So now if I look to the left, I see, if I look to the left and right, up and down, I see that I'm actually inside of the hole. Now, if you want to, let's go ahead and look at this. You can actually fly through the model. So if you wanted to go here, you can fly through these elements. And now you're inside of the model. So let's go ahead and zoom out or move out. So this is a very useful tool if you have a large assembly. You need to go and fly through the model to look at maybe displacements or stresses. You want to look at where your RBE3s are configured. You can use the first person mode to quickly look at that type of information. Now, there you have it. In this quick demo, we created 2 new forces. We then quickly perform an analysis, and then we looked at some of the deformations all through a web browser. We looked at displacements, stresses, and so on and so on. Now, some of you might have some questions regarding this tool. So at this time, let me go ahead and go through these questions right now. One very important thing to know is that there are performance limitations. If you have a Nastran model that's maybe 1 billion degrees of freedom, your web browser is not going to handle 1 billion degrees of freedom. It's not going to be able to show you the Nastran model. So given the performance limitations, there are going to be additional limitations. You're going to see that you cannot perform complete workflows. You cannot mesh geometry in the pre-web app. You cannot create geometry. You cannot modify geometry. You have to create your mesh in a separate tool. Then you import the bulk data file to the pre-web app to continue configuring your Nastran simulation. So then the question comes up, okay, what's the pre-web app useful for? The pre-web app is very useful if you are new to MSC Nastran, if you're a student, if you're a new early professional engineer, if you're new to Nastran, you can use a pre-web app to learn how to define the forces, the moments, the materials, connectors, RBE3s. You can learn how to define multiple subcases, how to assign the loads to different subcases. This is a really good training tool, a really good teaching tool for MSC Nastran. I'll give you an example. Suppose you wanted to configure Sol 400. You would go to Solution Sequence. You would select Sol, Configure, and you would select Sol 400. So here on the right, you see it says Sol 400. Suppose you wanted to configure multiple steps. You would go to Subcases. You would create a step delimiter. Maybe you want to use substep. You would create a substep delimiter. Everything you do is immediately updated here on the right. You notice that I now have step for subcase 1. I have substep for subcase 2. If you wanted to define the analysis, maybe you want to define a nonlinear statics analysis, you can set analysis equal NO statics. And notice that the analysis command is immediately updated. So what I just showed you is very useful if you're new to Nastran, if you're a new engineer, if you're a new student. This will help you quickly learn how to use Nastran. And again, unfortunately, there's no meshing, so you have to use a separate mesher, import the mesh here, and continue your workflow. Now, there might be the question of what Nastran versions are compatible. We only support MSC Nastran. In some cases, you could use this tool to learn other Nastrans because they also use subcase, they also use displacement and stress. So if you wanted to modify the displacement command as an example, here, let me go ahead and select all the describers. So here, sort 1, sort 2, print. How do you modify the ODS command? Print and all. So if it's something simple like that, stress and displacement subcase, you could possibly use this tool with other Nastran versions, but the biggest incompatibility is when it comes to the results. The results that we use are stored in the H5 file. Those are the only results we use. If you use OP2 and only OP2, we are not going to show you the results because we do not support the OP2 file. We only support the MSC Nastran H5 file format. So when it comes to the results, we only support MSC Nastran because we only support the MSC Nastran H5 file. Now, how do we build this tool? So I'll get to that in a moment. One other thing to keep in mind, compatibility. Whenever there's a new preprocessor, you kind of wonder, okay, what's supported, what's not supported. Here, we are claiming that we support 99% of the Nastran keywords, parameters, bulk data entries, case control commands. We support nearly 99% of those. Here, if you look at the table, this gives you more information as to what we support. As of MSC Nastran 2025.1, we support Nastran supports 251 case control commands. The pre-web app the tool that I showed you a moment ago supports 251 of those commands. So there's 100% compatibility. For the parameters, same thing. We support 100% of them. Now, what about the bulk data entries? There are 953 bulk data entries as of MSC Nastran 2025.1. We support nearly all of them. We support 948 of them. We purposely did not select 5 of them because they are very rarely used bulk data entries. Almost nobody uses those bulk data entries. They really don't have a purpose. So that's why we purposely did not support the remaining 5 entries. Here you can see we support 99.5% of the bulk data entries. If you sum both columns and you divide them, you find that we have about 99% compatibility with MSC Nastran, which is a really remarkable number for a new preprocessor. Now you might be asking, how do we do this? This tool was developed in California, which I would argue is kind of like the world headquarters for AI and machine learning. We have a few individuals who are really, really good at machine learning and AI from San Francisco, California. We were able to take advantage of a lot of machine learning and AI technologies like ChatGPT and DeepSeek. What we did is we tasked the AI algorithms to find the best approach to support almost all of the bulk data entries and case control commands. Given the feedback from ChatGPT and DeepSeek, we were able to quickly find the best path to support almost all of the bulk data entries, parameters, and case control commands, executive control statements, file management statements, and Nastran system cells. So a big congratulations and a big thank you to the team or experts in machine learning and applications. They were able to help us get to this point where we can now experiment with Nastran to a really high degree. Okay, now one last thing, pricing. Since we were able to quickly develop this tool, we can actually make the first license of the pre-web app free for professional engineers, for researchers, and professors. So if you're a professional engineer that's new to Nastran, the first license is free for you to use. If you're a professor or researcher, the first license is free for you to use. Now, for various reasons, we will have to have a small processing fee. The processing fee is going to be really small. It's going to be the price of maybe a video game, which range between $10, $40, and $80. Alternatively, it's going to be a few cups of coffee. This tool is not going to be $10,000, $50,000, or $20,000. No. This is only going to be a few cups of coffee or one video game. And that's just the processing fee. There are various reasons why we're implementing a very small processing fee, but overall, the first license is free for professional engineers, professors, and researchers. Okay, now let me see if there's anything else to answer here. I think the last thing is to share my contact information. So just in case you do have a question, if you have some feedback, some comments, feel free to contact me. My name is Christian Aparicio. And here's my email address, christian.aparicio@theengineeringlab.com. So there you have it. That is an early look at the pre-web app to configure and perform, or rather, that's the pre-web app to configure Nastran analysis, to run Nastran analysis, and to look at the Nastran results all through a web browser. Thank you for watching.